Hello guys, today I'm going to be going through the Spring4Shell, the CVE that was found back in 2022. So, okay, I've already deployed the machine, I've already connected to the VPN, we'll dive right into this. So, introduction and deploy. In late March 2022, two remote command execution vulnerabilities in the Java Spring framework were made public. The first of these vulnerabilities affects a component of the framework called Spring Cloud Functions. Arguably, more serious vulnerability. I'm sorry. Okay. The second, arguably more serious vulnerability, affects a component in Spring Core, the heart of the framework, thus significantly increasing the vulnerability's potential impact and earning it the name of a Spring4Shell. A play on Log4Shell, the name of a brutal vulnerability disclosed at the end of 2021. For various reasons, there has been a lot of confusion surrounding these vulnerabilities in the wider InfoSec community. As such, this rule may be updated as new information comes to light. On a similar note, the impact of Spring4Shell is currently unknown. Only time will tell how widespread the vulnerability is in the wild. This rule will provide an overview of the Spring4Shell remote code execution vulnerability in Spring Core, as well as give you an opportunity to exploit it for yourself in the vulnerable machine attached to this task. We will start by taking a look at the vulnerability at a high level, before exploiting the target machine for ourselves. Let's begin. I'm sorry, guys. I've got a little bit of a cough, but we'll still learn today. So overview: Spring4Shell was originally released as a 0-day in a now deleted thread of tweets. Okay, it was quickly identified as a bypass of the batch for CVE-2010, a vulnerability in earlier versions of the Spring framework, which allowed attackers to obtain remote command execution by abusing the way in which Spring handles data sent in HTTP requests. In short, the vulnerability allows attackers to upload a web shell, a piece of code which accepts commands from the attacker that the web server is then tricked into executing, to the vulnerable server, achieving remote command execution. So how does it work? To understand Spring4Shell, it is important that we understand CVE 2010. The Spring MVC Model View Controller is part of the Spring framework, which makes it easy to develop web applications following the MVC design pattern. One of the features of Spring MVC is that it automatically instantiates and populates an object of a specified class when a request is made based on the parameters set to the endpoint. Okay, so one of the features of Spring is that it automatically instantiates and populates an object of a specified class when a request is made based on the parameters sent to the endpoint. In simple terms, this could be abused to overwrite important attributes of the parent class, resulting in remote code execution. Spring4Shell works along similar lines, bypassing the mitigations that were added to patch CVE 2010. The majority of the exploits for the Spring4Shell vulnerability operate by forcing the application to write a malicious JSP file. Effectively plain text Java, which Tomcat can execute, much like a PHP web server would execute files with a PHP extension to the web server. Okay, this web shell can then be executed to gain remote command execution over the target. Limitations. Fortunately, despite how commonly used the Spring framework is, the conditions in which the vulnerability can be exploited are actually fairly limited. The Spring4Shell vulnerability affects Spring Core version 5.2 as well as in versions 5.3 and 5.2, this one, running on a version of the Java Development Kit greater than or equal to 9. Okay, or equal to 9. The publicly available exploits currently available only work on applications deployed to Apache Tomcat as WARs. However, the Spring Framework maintainers have stated that they believed there may be other ways to exploit the vulnerability. Current condition for vulnerability, as stated in the Spring's announcement of the vulnerability, can be summarized as follows. So you need a Java development kit of version greater than or equal to 9, a vulnerable version of the Spring framework, which has to be less than version 5.2 or these versions, Apache Tomcat as a server for the Spring application, packaged as a WAR, a dependency on the Spring Web MVC and or Spring Web Flux components of the Spring framework. It is worth noting, however, that these may change over time as other ways to exploit the vulnerability are discovered. Remediations. Fortunately, For patched versions of the framework have been released to remediate Spring4Shell and ensure that you're using a version of Spring released after patch 18 of minor release 5.3 or after patch 20 if using minor release 5.2. Upgrading the version of the framework is enough to remove the vulnerability from your applications. If upgrading is not possible, it is possible to somewhat mitigate this vulnerability by setting a block list of vulnerable field patterns. More advice on this can be found here. Okay, let's quickly skim through this. Yeah, okay, the first was to do the Spring framework, yeah, sure. Maybe in a position where upgrading is not possible to do good for that reason, we have raised some workarounds below. Upgrading Tomcat, downgrading to Java 8, disallowed fields. I want to check the disallowed fields. So another viable workaround is to disable binding to particular fields by setting disallowed fields on. Okay, so data miner said disallowed fields denial list on web data miner. Okay. In particular, from control sets is locally through its own init vendor method, which overrides the global settings. Okay. Okay. So let's continue. Let's do the exploitation now. Okay. Downloading the exploit. Let's download the exploit. Okay, so what I want to do is just okay. No, it's not a CTF though. What was the name of the file that we downloaded? Exploit. It's a zip. Exploit what? -16 form. Okay, so I want to move in here. And then I want to unzip it. What do you mean password? Exploit by password. Okay. We've covered the theory, now it's time to exploit the target. As this is a network-based exploit, you will need to use a TryHackMe attack box or a local VM in order to run the exploit. Copies of the exploit code can be contained in 3 places. Attached to this task, accessing using the blue download, on port 8080 of the target machine, okay, directly on the attack box. Okay, use whichever method is easiest to obtain a copy of the exploit zip file. The password for this archive is this little thingy, TryHackMe123. Okay. So let's quickly explore the exploit. This is how it looks. It's a Python exploit. That's requests, parse, exploit, URL, file name, password, directory. Suppose URLs, okay. Okay, yeah. Just upload the shell. Then exception, yeah, sure. Okay. Okay, so script, yeah. When you unzip the archive, you should find a single Python script. Yeah, this is a modified version of the proof of concept that is currently circulating online. It is slightly more user-friendly than the original obtained here. However, you may use whichever version you wish. This task will assume. I just want to check at the not-so-friendly version of it. Where's the exploit? Okay. However, you may use whichever version you wish. The task will assume that you are using the code provided. The exploit. Read through the exploit code and ensure that you are happy that it does what it claims to do. You should always review unknown exploits before running them. I understand that. Having satisfactorily completed our code review, let's start by taking a look at the help menu for the exploit. Sure. Just expecting filing. Okay. The script requires one argument, URL. Okay, this specifies the target for the post request. The other three optional arguments can be ignored in the current context. Let's start with taking a look at the website in browser. Sure, let's take a look at the website. What do we see here? Our website is coming soon. We're working hard to finish the development of the site. Sign up below and receive updates and to be notified when we launch. Okay. We can easily find our target URL by checking the source code of the website. What do you say? But I already had the IP address. What are you talking about? Okay, let's keep reading. At the website in browser, yeah, okay, we easily find our target URL by checking the source code of the website homepage. Yeah, sure. Specifically, we're looking for the action of the contact form, the only post request available to us. This is found on line 20. Oh, okay. Is that it? Oh, okay, here. There's a post method. Okay. The action is this one. Okay, meaning that our target URL will simply be this one. Okay. Note, the trailing slash is very important here. Okay. So, attack. Time to use the exploit. Execute the script. If you're using the attack box, navigate to the no. You should receive output similar to the following. Let's do it. This is how we do it. Okay, so we're specifying the URL, which is the only required parameter here. The others are optional. So shell uploaded successfully. Your shell can be found at. Okay, that's interesting. Root. Okay. Okay, so navigate to the link provided by the S2C in action. You can change which command gets run by changing the CMD parameter. By default, the command is who am I? Oh, okay, sweet. So what if I just I want to know where I'm at? Okay, okay. So that's sweet. Has been successfully once. Okay, you can change which command. Yeah, sure. Once the upload has been used successfully once, it cannot be used again until the application has been restarted. If you upload the web shell with the wrong name or directory path, then you will need to terminate and redeploy the target machine. Follow the steps in the task to exploit the Spring4Shell and obtain a web shell. I already got this. Use your web shell to obtain a reverse bin shell on the target. Okay. Let's see if we get something. Yes, we get the flag. Okay. But they're asking me, this is a bonus optional. Use your web shell to obtain a reverse bind shell on the target. So I do want to do that. So how do we do that? We are on a command, right? So I guess it should be bash. So if I put this on, what is my IP though? Config, my IP is 10.6.61. Okay, 9006. So if I do this inside here, okay, so if I do this, I need to set a netcat LBMP 9006 if I'm not mistaken, right? 9006, yes, okay. So we are gonna just execute this and see if we get the reverse bind shell. Did we? Nope. Oh. Assuming the shell is bash, so. Run this again. Then we got this. Okay. So do we get anything? Not really. Okay. Oh, it's command. Is that it? Is that it? Okay. So let's just try this one as well. Could it be that they're asking me for? Not really. Okay, I'm not able to get a shell, but I guess this should do. I need to practice more reverse shelling and stuff, you know. So let's do that. Mark this is done. And congratulations, you have reached the end of the Spring4Shell room. Having completed this room, you should hopefully have a high level understanding of the vulnerability and be comfortable attacking applications vulnerable to CVE 2022. As mentioned previously, this vulnerability has the potential to be very widespread, but only time will tell how serious its role is. Keep an eye out and make sure that you patch any systems you're responsible for. If you would like to read more about Spring4Shell, you may find the following resources informative. I understand can use Spring4Shell. Okay, this was it, guys. Thanks for sticking with me. Yeah, peace.